Hello, good morning. I'm discussing Langmuir adsorption isotherm. Friendly's propose adsorption equation without taking any theoretical considerations. But Langmuir tried to explain type 1 adsorption isotherm by making certain assumptions, postulates. Adsorption is always monolayer. Adsorption is a reversible process. Forward process is adsorption and backward process is desorption. At equilibrium, these two processes are equal. Each adsorbent consists of different adsorption sites, and heat of adsorption is constant for each site. Adsorption site only one molecule, monolayer. The surface solid is homogeneous, same affinity. Only monolayer is formed on surface, no lateral interaction. Adsorbed molecules localize that can not move. Derivation: let theta be the fraction covered by gas molecule and P is equilibrium pressure. Then 1 minus theta be the fraction uncovered by gas molecule. As stated previously, rate of adsorption is proportional to 1 minus theta. That is rate of adsorption proportional 1 minus theta R A equal to Q1 1 minus theta P. Rate of desorption proportional theta RD equal to K2 theta, where K1 and K2 proportionality constant known as adsorption constant and desorption constant respectively. Rate of adsorption equal to rate of desorption, so RA equal to RD. So K1 minus theta P equal to K2 theta. Simplifying, K1P minus K1 theta P equal to K2 theta. K1P equal to K1 theta P plus K2 theta P, taking common theta equal to K1P over K1P plus K2. Dividing the numeration and denomination of equation 1 by K2, then we get theta equal to K1P over K2, K1P over K2 plus K2 over K2, theta equal to BP over BP plus 1, theta equal to BP over 1 plus BP, B equal to K1 over K2 is a constant. As the gas molecules are assumed to form a layer, the extent of adsorption Y equal to X over M depends on fraction covered, that is X over M proportional theta, X over M equal to K3 theta, quotient 3, where K3 is constant quantity, substituting value of theta in equation 3rd. Then X over M equal to K3 BP over 1 plus BP, X over M equal to AP over 1 plus BP. So A equal to K3B is a constant quantity. Equation 4 is known as Langmuir equation and the constant are known as Langmuir constant whose value depends on nature of gas adsorbed, the nature of adsorbent and temperature. Validity of Langmuir equation, we have x over m equal to AP over 1 plus BP. On rearranging above equation, x over 1 over P equal to A over 1 plus BP. Taking reciprocal, P over x over m equal to 1 plus BP over A equal to 1 over A plus BP over A. Solving P over x over m equal to 1 over A plus B over A P. This equation is in the form of y equal to mx plus c, where y equal to P over x over m equal to B over A, and c equal to 1 over A, x equal to P. So plot of P over x over m versus P gives a straight line having the slope B over A and y-intercept is 1 over A. The value, and using this value, we can determine the value of B from slope. Limiting case of Langmuir equation, we have Langmuir equation x over m equal to AP over 1 plus BP. At low pressure, BP less than 1, so that value of BP can be neglected as compared to 1 in the denominator of equation 1. So x over m equal to AP, x over m proportional P. At very high pressure, BP is greater than 1, so the value of 1 can be neglected to BP, x over m equal to AP plus B over BP, x over m equal to A by B, x over m proportional P naught. That is, the extent of adsorption is independent with the pressure for intermediate pressure range. X over m proportional P 1 over x, where 1 over x lies between 0 to 1. Then a plot of x over m versus P should be thus, from the above discussion, we conclude that Friendly's equation is a specific case of Langmuir equation. Limitation of Langmuir isotherm at low pressure, this equation is fairly good, but at high pressure, it cannot give the exact relation between extent of adsorption versus pressure. This theory can describe only for the formation of monolayer, that is the relation between heat adsorption and surface area covered, which was not mentioned by Langmuir. Okay, it's all about Langmuir adsorption isotherm. Thanks for watching and request you all like, comment, share, and subscribe. Thank you for patience. That is now bye bye.